Hello everyone, this is your mathematics educator Abhinav Jha, and I hope everyone is doing absolutely amazing and learning how to learn with Maths Unleashed. So today we are going to do an exciting session. So this is my brief credentials. You can obviously search my profile on YouTube and Google. I'm the proud mentor of All India Rank 1 RK Shishir in 22. Okay, so guys, we are going to use some amazing techniques today of mathematics and obviously see that which are the different careers that use math on daily basis. Amazing session. Let's proceed. Okay, so guys, obviously first is data scientist. So data scientists use mathematics heavily across industries like tech, finance, obviously healthcare, retail, wherever you go, they obviously use the mathematics on regular basis. Okay, so what are the maths that are used in them? Is first is statistics, probability, linear algebra, and data modeling, right? So what they do is they obviously identify the complex data, right, and then they predict trends of future using that. Okay, and they build predictive models. That's what I'm talking about. Predicting the future is something which is very important, right? Analyze these datas and obviously make it easier for the future generation, and obviously make things which can be done in a recurring fashion, right? So that hard work is less, output is more, right? So that is what actually data scientists do, and data is going to be the next superpower, right? And obviously this data scientist career is a very flourishing career right now in the 21st century, currently standing in 2025. Okay, also it helps companies make data driven decisions, right? You have to make decisions on daily basis in your conference rooms, right, and in the board meetings, across the table, everywhere, across the globe, and for various finance, tech, healthcare, retail, any department you see, data scientists going to use these data, take help of the mathematics, statistics, probability. They are going to generate a lot of trends. Okay, let's look into the next one. Next is the actuary, right? So actuary is actually, you can say, these are the insurance companies which actually use mathematics on regularized basis in order to predict the trends. Like there was, let's suppose, X amount of purchase of the insurance and how many of them claimed it. So they can use probability of the last 20 years data and predict that whether they are in profit, they are in loss, if profit, how much profit, and how can they scale their company, right? Scaling is something that every company looks for, right? In order to go for IPO or in order to expand their business, right? Get more funding. Scale is something which every company looks for, and that is why probability and statistics data will help them to scale, right? So extremely math intensive, high paying and very respective job is that, right? If you are at the top position in these companies, they assess the risk of insurance companies, right? Pension funds, right? Businesses and mathematical models, right? So basically they deal with these. I talked about the insurance company and the pension funds, right, which we are generating. Obviously government, there are a lot of EPFs, right, and a lot of the other provident funds that the government offers. The government companies also use these data, right? Okay, let's proceed. Then engineering discipline. So this goes without saying that any kind of engineer you are, whether that's electronics, communication engineering, computer science engineering, mechanical, civil, electrical, everywhere you go, heavily differential equations is used, calculus is used, right? If I am applying a certain force in an object or a beam, will it crack or not, will it fall or not, will it be able to take that heavy load? That's what civil engineers and mechanical engineers basically check, right? Whether that will be steel design or RCC design, brickwork design, right, or a motor vehicle design. Thus mathematics is used amazingly each and every domain taken, right? And computer science engineering, obviously the AI, right? Obviously I'm going to come back to that in a certain time period, but yes, computer science, coding, it's all about logic. The more you practice mathematics, it's the indirect use you're getting, right? Not always direct use you will see in different domains, right? If you practice the probability, if you practice solving tricky logical questions on daily basis, your mindset is changing, your mindset is improving, your IQ is improving, and you are going to program in a faster way, right? And with that said, obviously AI is there. Obviously they are saying that the coding might be of no use of manual coding I'm talking about, because AI would write the codes in the future. Some people are saying that, but ultimately to do anything, your logic should be actually picture perfect. Okay, so coming back to the next point, right? What are the mathematics that they use? Obviously design systems, machines, structures that I have been talking about in depth, and solve problems using precise mathematical calculation. Because see guys, code might go wrong here and there, but obviously buildings, structures, they can't fall. There cannot be even 1% of doubt that that is not possible. There has to be picture perfect calculation, right? It has to be exactly perfect, right? Minimal of the things if you make it wrong, like dam designing, construction of roads, construction of bridges, railway lines, if you make small mistake, be manpower loss, human loss, right? So very dangerous. So that's why the calculations are very, very financial analysis, right? Obviously today's stock market, right? You have the trends, right? If you can see that, okay, Nifty 50 has grown by, let's suppose, 15.8% the last 10 years. So if I just go by the same number, or in fact something lesser than that, what would be the money which I'll be getting if I invest for 2 years right now, right? What happened after recession? What happened after election? Right? Recession and elections, these are the two main domains of uh, fundamentals of stock markets increasing and decreasing, right? Where do you get that trend from? You get that from mathematics, statistics, ratios, forecasting models. These are the things which daily basis the financial analysts use, right? They make these creative investment strategies, which help them to manage the risk, and they increase their business. That, okay, let's go for the next thing, that is machine learning, right? Central to the AI, right? Automation, tech innovation, right? So obviously this is heavily AI based system which I'm talking about, right? Lot of IITs and the other institutions are using AI on daily basis, and they are teaching the students on daily basis. What are they using? They are using linear algebra, calculus, probability, and statistics, right? So if you have an idea of these things, you can design the machine learning. Obviously can be given the input, and the output can be taken in a right manner, right? So building algorithms which allows the computers to learn, right? These are inputs that you make the computer learn those things, and then they can work on that. That is what actually artificial intelligence is, right? Data like recommendation systems and chatbots, self-driven tech. Everyone wants nowadays that the bot should do everything, right? So if you can build a tech around that, can be a multi-billion company, right? So yes, today is the day and age of AI. Yes, you need to learn those typical concepts which obviously are important, languages, coding languages, but ultimately the foundation, the stepping stone, the basic is mathematics. Okay, so thank you guys for watching this amazing session. Going forward, we will be doing such many sessions, and obviously do not forget to like, share, and subscribe this channel to learn maths